Hello, I'm Paola, and in this video I present my paper Power and Resistance in the Twitter Bias Discourse. First, I'll introduce the case study of Twitter's saliency-based image cropping algorithm, then I'll lay out my theoretical perspective, and then I'll proceed in 3 acts: power, resistance, and stabilization. When a Twitter user includes 1 or more images in a post, the platform crops the images to create a preview in the timeline. In doing that, the built-in mechanisms determine what is to be seen in the preview and what not. In 2020, several Twitter users raised accusations of racial bias, claiming that Black persons were systematically being erased. As a response, then Twitter researchers published an in-depth bias analysis, and the bias-prone tool was removed. Then Twitter hosted the first algorithmic bias bounty competition, in which everybody was invited to detect harms caused by the algorithmic tool. Twitter's image cropping algorithm is a fascinating case study for exploring the push and pull dynamics of power relations between, firstly, algorithmic knowledge production, secondly, the bias discourse as resistance, and thirdly, ensuing corporate responses as stabilization measures towards the resistance. In order to account for the 3-part narrative of this case study, this paper examines the following 3 questions. How is the algorithmic and especially the database knowledge production around the image cropping tool entrenched in power relations? Second question, in what way does the discourse around bias serve as a vehicle for resistance against said power? Why and in what way is it effective? The third question, how and to what extent did Twitter as a company stabilize its position within and in relation to the bias discourse? This paper employs a 2-fold interdisciplinary theoretical perspective, combining, firstly, an intra-mathematical perspective that examines the mathematics underlying both machine learning systems and bias analyses, with, secondly, Foucauldian concepts that make it possible to view mathematical tools as articulations of power relations. Foucault's concept of power has many facets, and in the following, this paper focuses on power as the multiplicity of force relations immanent in the sphere in which they operate. Power relations make us do things. As such, power produces reality. And power is not something to be had, it is dispersed, always being negotiated and always being reconfigured. And power is intrinsically connected to knowledge. In the context of this paper, knowledge includes, for example, every output of a quantitative method, specific image crops, as well as results of bias analyses. Knowledge, however, does not stand for itself. Discourses are ways in which meaningful knowledge and thus reality is structured and created. Act 1. Power. In 2018, Twitter introduced a cropping system that centered a crop on the most salient area of an image. Saliency was assumed to be a good indicator for the most interesting regions of an image. And a supervised machine learning models predicts the most salient areas of an image. The training data consists of images, and the labels are the corresponding saliency heat maps that are obtained by measuring eye movements of observers who look at the images. The data that was used to train the model is publicly available. Looking at this through a Foucauldian lens, power relations shape societal viewing patterns on the top left. The individual acts of the eye-tracking participants are capillary bodily acts, and these acts are aggregated via the distilled saliency maps and transposed into database knowledge via the model. This knowledge in the form of the image cropping mechanism is amplified to millions of user screens. Quite literally then, power becomes knowledge and knowledge becomes power. This, of course, assuming that the tool functions as it's supposed to. Act 2, resistance. In my paper, I examined 3 bias analyses of the cropping tool. Yi et al. And Birhani et al. Use a multi-image approach in which they concatenate pairs of images of one demographic group each and observe the saliency predictions behavior on these demographic groups. They curated datasets of 4 intersectional demographic groups: Black male, Black female, white female. And according to the fairness metric of demographic parity, the cropping tool should treat the demographic groups roughly equally. Kulinich uses a single image approach in which he fabricates synthetic face images using a gun, optimizing for maximal saliency. He then looks at the images and observes what kinds of changes to the face increase the saliency. All 3 analyses conclude that the tool is indeed biased. However, in order to measure bias, one has to define it, and defining bias requires an underlying concept of what is alike and what is different. Bias then is a differentiation made by an algorithmic system that is in some way undesirable. In the fairness metric of demographic parity, for example, comparability is implicitly defined as 2 images of faces that are concatenated horizontally or vertically. Confronted with these similar images, the model should not be systematically favoring one demographic over another. Similarity and difference, however, are concepts that are difficult to define robustly in visual data. Birhani et al. Stated that even changes in the saturation of the images or in the width to height ratio yielded different results. And in my paper, I extensively discussed the limitations to bias testing and conclude that the knowledge produced in bias analyses is porous. Research and studies on bias, reports by NGOs, works of popular science, just to name a few, form a discourse of knowledge practices that stabilize the epistemic limitations to bias testing. In this case study, individual Twitter users, the bias testing studies, commenters, etc., form in Foucauldian terms a swarm of points of resistance against the power exercised by the image cropping tool. A bias discourse in itself was effective. The tool was removed. Act 3, stabilization. In July 2021, in a quite novel way of reacting to criticism, Twitter adapted the bug bounty challenge format common in IT security and launched an algorithmic bias bounty challenge, a competition in which everybody was invited to find biases and harms in the context of the cropping tool. Twitter awarded $7,000 in total as bounty prizes. From a technical perspective, it's to be noted that the prediction model was not made transparent. Also, compared to regular bug bounties, the total monetary compensation was relatively low, and all participants who did not get one of the 5 prizes were not compensated for the work at all. Twitter created a constellation in which the company was able to benefit from unpaid labor. Quite literally, power produced knowledge. The bias bounty functioned as a means of stabilization for Twitter's then self-representation as an ethical and transparent tech company. This has obviously drastically changed since the beginning of the Elon Musk era, when Twitter's AI ethics team was disassembled. At the time, however, the strategy was effective. Twitter found a comfortable place within the bias discourse. As for a few remarks on the limitations of the study, the choice of materials brings with it certain limitations. Of course, having to rely on public statements and blog posts by Twitter entails a lack of intra-organizational perspective that does not see intra-organizational power struggles. And especially considering recent developments, one must assume that Twitter as a company has never been one homogeneous actor. And all in all, this paper examined the push and pull dynamics of power relations surrounding the production of knowledge in machine learning systems as well as in bias analyses. It turns out that the bias discourse can be a very effective vehicle for resistance against algorithmic power and for counter-resistance too. All details can be found in the paper, and thank you so much for your attention.